Well, hello 2D, and welcome back to a new approach to factoring complex trinomials. This is called the bottoms-up approach, and it's just one more tool in your toolkit for factoring. In some ways it's easier, and in other ways it's more difficult than the guess and check method that we used in the previous lesson. So what we're going to start with is this step one. We're going to change a complex trinomial into a simple trinomial. So here's what a complex trinomial looks like. It looks like ax squared plus bx plus c. And the way we're going to change that into a simple trinomial is we're going to multiply the a by the c, so the front number by the back number. Okay. And what we get is a new trinomial where we have x squared plus bx and then plus what we get when we do that multiplication, AC. Now, that might look kind of weird in the general case, but we're going to do it in this specific case here. So what we have to do is take the 5 and times it by the 12. And we're going to write our new trinomial as x squared plus 4x minus 60. Now, notice I did not put an equal sign there. Do not put that equal sign there. These two expressions are not equal. We're just going to use the simple trinomial that we found to try and help us factor the more complex trinomial. So now we're just going to work with the simple trinomial, and we're going to factor it the way we normally would. Put your two brackets down. We know we have x's at the start of each bracket. And we're going to read this backwards. So we need our two numbers to multiply to 60 and subtract to 4. Okay, so what two numbers multiply to 60 and subtract to 4? That's pretty straightforward. That's the 10 and the 6. Those multiply to 60 and subtract to 4. And since this tells us our signs are different, we know we have to have one plus and one minus, and this tells us that they must have had more positives than they were negatives. So now we've got that factored. Okay. The next step says we need to fix the change we made in step 1. So in step 1, the change we made was multiplying the constant by this front coefficient. So in order to change it back, we're going to divide the constants by the front coefficient. So what that's going to look like is we're going to put a divide by 5 under each of the constants in the factors. That's what this says. Fix the change you made in step 1 by dividing the constant of each factor by the original coefficient of x squared. Reduce to lowest terms. So we're going to reduce it to lowest terms, and what we get here and here, 5 goes into 10 two times, so this ends up being 2 over 1, and there's nothing I can reduce there, so I'm going to leave that as 6/5. Now the next step says, now bring that bottom up to be the coefficient of x in each new factor. So if I'm looking here, I'm going to take this bottom, whatever it is, and put it up here. So our new expression is going to become 1x plus 2, and the second one is going to be 5x minus 6. Now if you want, you can expand that just to satisfy yourself that it is the exact same as our original trinomial. So 1x times 5x is 5x squared. Then I'm going to get a negative 6x, a positive 10x, and a negative 12, which means that I have 5x squared plus 4x minus 12. Now these things are all equal to each other, and if you take a look up here, they're also equal exactly to what we started with, 5x squared plus 4x minus 12. So that was quite a bit simpler. There's no guessing, there's no checking, there's no going through a whole bunch of different choices to find the right one. But please be aware that this, since we're doing that multiplication in the first place, your numbers can get big awfully quick. So if you're looking at big numbers, sometimes the guess and check method is still good. It's also very important in this method that you take out any common factor first. So we're going to do a few of these on our own, and then I will actually show you what happens if you miss that common factor. So taking a look at this question, there is a common factor. All three of these things can be divided by 5. And if I take the 5 out, I get p squared plus 14p plus 8. Oh, 5p squared, sorry. Now our next step is to multiply that front coefficient by that one, and then we're going to work with that new trinomial. So when I multiply that out, we're going to get p squared plus 14p plus 40. Now let's factor that. P's at the front. Signs are both the same and they're both positive, so we can put them in right now. And we have to multiply to 40 and add to 14. Oh, well, that's easy enough. That's 4 and 10. Now remember, once you're done that, you got to fix it because I did not give you this trinomial to start with. Let's do the fix. The fix is to take that front coefficient, which is 5, and put it underneath each of these constants and reduce to lowest terms. So this is already in lowest terms. This can reduce because 5 goes into 10 twice and 5 goes into 5 once. And then we have to take this bottom and it makes it our front coefficient. So if we take that bottom and it makes it our front coefficient, we end up with 5p plus 4 and p plus 2. Now don't forget this. It's still part of that, so this is our final answer. Let's do a few more. There's no common factor here, so we just multiply that, and we're going to factor b squared plus 5b minus 24. That's what I get when I do 4 times negative 6. So put our two brackets down, b's at the front. We have to multiply to 24 and subtract to 5. Well, that's 8 and 3. The signs are different, and I need more positives, so I got to put the positive with the 8 and the minus with the 3. Now let's fix it by taking and dividing each of these constant terms by the coefficient at the front, which is 4. This doesn't reduce, but this one will. 4 goes into 8 2 times, so we have a 2 on the top and a 1 on the bottom. Now we got to bring the bottoms up, and we end up with 1b plus 2, and on this side 4b minus 3. And there is our final answer. Now I'm not putting equal signs all the way down because each of these steps are not equal. This is just kind of a shortcut to getting to the right answer. Over here again, we're going to take the 4, multiply it by the 5. So what we end up with is p squared minus 12p plus 20. Now let's factor this one. P's at the front. What multiplies to 20 and adds to 12? Well, that's 10 and 2. That's pretty straightforward. We know the signs are the same and they're both negatives. So let's put our negatives in. Now it's time to do the fix. We multiplied by 4 in the first step, so we have to divide by 4 in this step. Now we're going to reduce. Both of these things reduce to lowest terms. 2 goes into 10 5 times, and 2 goes into 4 2 times. Now over here, 2 goes into 2 1 time, and 2 goes into 4 2 times. Now we have to do bottoms up. When we do bottoms up, this 2 comes up to be with this p, and we have 2p minus 5 and 2p minus 1. And there's our final answer. Carrying on, got to take a look. No common factors here. So we're going to multiply the 4 by the 25, and we get x squared minus 15x, and then 4 times negative 25 is negative 100. Okay, so now 100's a bit of a big number, but it doesn't have that many factors, so there's not too much to worry about. Put our two sets of brackets down. We know we have x's at the beginning. Signs are different, so let's not put them in just yet. We're multiplying to 100 and subtracting to 15. I can hear your brains turning. 20 and 5. Okay, and we know we need more negatives. This tells us there's one of each. This tells us there's more negatives, so we got to put the negative with the 20 and the positive with the 5. Okay, now let's do the fix. We multiplied by the 4 in the first step, so we have to divide by the 4 in this step. and reduce to lowest terms. Here's the reduction. 4 goes into 25 times, and 4 goes into 4 once. So our answer is x minus 5, and in here the 4 comes up, so we got 4x plus 5. And that is our final answer. Now this last one, there's a little bit of a trick to, and I'm going to pretend that I don't see the common factor. If you take a look, there's a common factor of 3 in each of these things, but I'm going to forget about that. I'm not going to look at it. I'm just going to look and say that I have to do something funky with these x cubes and x to the 6th. And it's not even really all that funky. I just know that when I put them at the beginning of the brackets, there has to be an x3 here and an x3 here, so that when we multiply x to the 3 by x to the 3, we get x to the 6th. Okay. And I'm going to do this here where we do 6 times 9, and that's going to give me x to the 6th plus 15x cubed minus 54. Okay, so now we want to figure out what multiplies to 54 and subtracts to 15. Now 54 is something that you may not have worked with a lot. It's got quite a number of factors. So let's actually start getting out all the factors. So we know 1 and 54 is an option. Remember, we're going to start with 1 and 54, and then we're going to go up. 2 and 27. Does 3 go into 54? Well, if you're not sure, take your calculator and do 54 divided by 3. And yes, it does. It's 18. How about 4? Does 4 go into 54? 54 divided by 4 is 27 over 2. So no, 54 does not divide by 4. How about 5? Well, it ends in a 4, so that's a no-go. How about 6? Well, we just got that. We know it's 6 and 9. Okay. So we're looking for something that subtracts to 15. Well, this is the one that subtracts to 15. 18 and 3 subtract to 15. So let's put in our 3 here and our 18 here. We know that the signs are different, and this tells us we had to have more positives. So there's a positive here and a negative here. Now we've got to do our fix. So we times by 6 before, so we've got to divide by 6 now. So reducing to lowest terms, 3 goes into 3 once and into 6 twice. 6 goes into 18 3 times and into 6 once. So now we got to bring that bottom up, and we have 2x cubed minus 1 from here, and x cubed plus 3 in this one. And you may be saying, well, what was the problem? You said you forgot that common factor. Well, it factored, it's great. No, but what if we do expanding? So if we tried to expand this, we'd have 2 times x, 2x cubed times 2x cubed gives us 2x to the 6th. And then here, 2x cubed times 3 gives me plus 6x cubed. And then we have minus x cubed from here, and then minus 3 from here. And our total would end up being 2x to the 6th plus 5x cubed minus 3, and that is not what we started with. But what happens is when you reduce to lowest terms, that gets rid of your common factor. So I know that this 2 should have been a 6, which means that there must have been a 3 out front that I forgot about. And if we take a look, if we multiply everything here by 3, then we get the original thing. Okay, so if you forget the common factor, you can still make a fix afterwards if you take a quick look and make sure that everything multiplies out correctly. And if it doesn't, just make that correction and say, oh, there must have been a common factor of 3 out front. So this is the answer we're looking for. And that's everything. I hope that this method maybe is a little bit easier for some of you.